In this unit, we're going to take a look at motion. And the first thing we have to understand about motion is that all motion is relative. And what I mean by that is it doesn't make sense to talk about motion in isolation. We have to talk about what we're moving relative to. So motion is relative to whatever we're comparing ourselves to. For instance, if you've ever been on a bus trip, you know that they take forever and you never seem to get where you're going. And the whole time you're just sitting there, you're talking to your neighbor. And your neighbor's sitting there talking to you, and the two of you are just having a lovely conversation about the weather or the game or whatever it is that's going on. And you can have that conversation because the two of you are not moving relative to each other. One of you standing in the aisle making the bus driver mad at you. The other one of you sitting in your chair, and you guys are not getting any closer to or further from each other. But if you happen to glance out the window and you see a tree, you don't expect the tree to remain outside your window. You know in a few seconds, if your bus is moving this way, you're going to have to look behind you to see that tree. And that's because relative to the tree, you moved. Relative to your neighbor, you didn't. You guys are in the same bus, moving the same direction at the same speed, so you're not getting closer to or further from each other. And so in order to describe motion, we need a frame of reference. And you can pick different frames of reference to describe different things in motion. So inside the bus, your motion, you're not in motion. If you compare it to outside the bus, you are. So motion is relative to your frame of reference. The frame of reference is what you are using to describe your motion. It's what you're moving relative to. So your frame of reference is how motion is described. Now, usually we don't need a whole bunch of stuff. I mean, we can compare it to the road and the trees and the lines on the road and the grass and the cows in the pasture and all that. But we usually just pick one point out of that frame and we call it our reference point. And we use our reference point in order to give directions or describe how we're moving. That's the one object we pick to measure from. So this is what we measure from. And what we measure for depends on what we're trying to describe. If we're trying to describe our motion, then we need to know how fast our position is changing relative to that reference point. If we're trying to describe where we're at, our location, our position, then we need to know a distance and a direction. So there's a couple things we have to know. We have to know what position is. Position is distance and direction from our reference point. Okay? So remember, our reference point is what we're measuring all this from. Position is distance and direction from that. By distance, we mean how far, and of course that means we need our unit. We measure that in meters. A lot of times we'll also use kilometers if the distances are big. Remember, 1,000 meters is the same as 1 kilometer. In direction, that we can use left or right, we can use up, down, we can use east, west, and you'll also see that we'll use plus, minus. Generally speaking, plus is to the right and minus is to the left. So position is distance and direction from our reference point. And the last thing is, so what do I mean if I mean I'm in motion? If I say I'm in motion, what do we mean? That means our position is changing relative to our reference point. Okay? So motion's relative. We always have to compare it to something else. Our frame of reference is what we're comparing it to. We use a reference point to measure from, and that helps us establish our position, which is our distance and direction from our reference point. And if our position changes relative to that reference point, we are in motion.